Okay, grade 11s. So, yeah, my mistake yesterday. I didn't realize it was just me not reading like I read what came from the office about our marks. Our marks are due tomorrow on Wednesday, but I'm sort of missed the whole credit intervention day. So it's bottom line. There's no class for you on Wednesday of this week, on Wednesday, May 19. But listen, most of you don't. We'll have a little bit of time here today. So if you wanted to do this assignment, it'll take a little bit of time. Okay, so there's no class, so this is your chance to get caught up on your work. If you are already caught up on all your work and you don't require the intervention, well, this is just a little assignment for you. Everyone's going to have to do it, whether you're catching up on work today. Eventually, you're going to have to do this. So just let me explain it to you. I mentioned it just sort of briefly in class on Tuesday, so I just wanted to go over that with you here. So what I'd like you to do is the following. For the following resources, okay, and it's all in your textbook in case you're wondering. These are the ways that we use to generate electricity, okay, in the province. Mostly it's electricity, but okay, take a look. Hydro is when you say build a dam, okay, and then you harness the gravitational potential energy in the water, okay, in that system, and then convert that into electrical energy in the wires as you let the water sort of flow over a turbine, spin the turbine, and create electricity. Solar panels, there's photovoltaics. So I have solar panels on my roof. I think I told you that before. Solar panels convert radiant energy from the sun into electricity. They have no moving parts. Okay, so solar panels. Wind power, they use the power of the wind to turn a turbine and create electricity. Thermal energy is when you use heat. Usually with thermal generation, what we do is we have a source of heat, whether it's burning fossil fuels, burning natural gas, burning biomass, burning coal, whatever it is, or nuclear power, which you don't burn anything, but there's a nuclear reaction which produces a tremendous amount of heat. And then that heat is used to create steam, pressurized steam, basically, okay, in a boiler. And that steam can spin a turbine. So it's all about, generally speaking, spinning turbines, except for solar panels, where there's no turbine involved. Okay, geothermal energy is using the heat from Earth's crust. So I think most of you would realize that if you drill down into the earth, you will eventually hit lava. It's very hot down there. So if you can tap into that thermal energy that's in Earth's core, we can use that as an energy source. Okay, and then finally, tidal energy is a form of hydro energy where we harness. You'd have to be on a coastal community to do this, like especially say the Bay of Fundy would be perfect. Where the tides come in, they can spin a turbine when they're coming in. They can spin a turbine when they're going out. Okay, so we use natural currents in the water then, these tidal currents, to create electricity. Now, here's the assignment. You describe each resource and you must include a diagram which you can find and copy online. It's probably the easiest way to do it. I'll show you an example in a second. So include diagrams or images, okay? And also the description should be in your own words. Please don't write like this, copy someone's like graduate level thesis on not on nuclear power, but say on hydroelectric power. And it's obviously not you that wrote it, and it is not the level of a grade 11 student. Okay, I don't want that. I just put it in your own words. It's pretty easy. Most of these things are pretty easy to describe. So please, in your own words, state 3 pros and 3 cons. And by the way, the first pro should be the best thing about that thing. Okay, so for example, what's the best thing about wind energy? Well, it's got to be that it's a resource that does not produce carbon emissions, right? That's got to be the number one good thing about wind power. Okay, now that's its best attribute. Same thing with solar panels. Okay, solar panels, there's a lot of good things about it. They don't require, there's no moving parts. They last a really long time, like up to 40 years, you know, and they require very little maintenance. These are all pros, but primarily the pro is that it's a renewable resource that does not produce carbon emissions, right? So wind and solar are green, you know, examples of what we call green energy. They don't produce carbon emissions, and that's very important. Okay, now cons. Cons, the first on your list of cons. Cons are things that are against this, like what's not good about it. The very first one that you should mention should be the worst thing about it. So what's the worst thing about wind energy? Well, the worst thing about wind energy is it's just not available 24 hours a day. And here's the problem. We live in a society that requires electricity 24 hours a day. So there's no way that wind and solar, which both have the same problem, they're not available 24 hours a day, there's no way that society could function on only those two things. Okay? Because we need electricity at night in the case of solar panels, which produce zero electricity at night. And we need electricity when it's not windy. Okay? And it's very often not windy enough to produce enough electricity in your wind farm, okay, to power, let's say, your cities and stuff like that, and towns. So that's the worst thing about wind power, you know. But with all the resources, there are good things about it and bad things about it. For some of them, the good things are maybe hard to see, like coal. You know, is there really anything good about coal? Well, there is one thing. In fact, there's a couple of things. Number one, it's pretty cheap. And, you know, we do care about how much money we're spending on things. Number two, it's easily transported. So if you want to have electricity out in the middle of nowhere, let's say in Nunavut or whatever, where they don't get a lot of solar power and they don't have a lot of options for hydro and stuff like that, well, what about coal? You know, you can transport the coal up there pretty easily. It's a solid substance, right? And then you can use that to generate your heat and electricity. Is it clean? No. I mean, that is the biggest con for coal, is how dirty it is. Okay, and so, you know, I mean, for the sake of the planet, despite the pros, okay, that coal has, we really need to stop using it. Okay, so that's, you know, it's not like fossil fuels don't have any pros. Okay, like I know they've been getting panned lately because of all the environmental effects, and I know, I totally understand that makes perfect sense. Those are the cons. But there are reasons why we still need to use them today, okay? And we need to find alternative solutions to using these things in these remote areas and stuff like that. Now, quite frankly, if the only place we use coal was or fossil fuels in general was to produce heat and electricity in the most remote areas, and that's all we did, in other words, none of our cities used it, none of our transportation sector used it or anything like that, well, then we would solve the greenhouse gas problem anyway. Okay, like, I mean, that'd be the end of it in terms of our carbon emissions. So, 3 pros, 3 cons. Okay, that shouldn't be too hard for you to find. Now, we talked about what a kilowatt hour is. A kilowatt hour is equal to 3,600,000 joules. It's 1,000 watts times 3,600 seconds, which is equivalent to 1 hour. And we get charged by energy consumption according to the unit of kilowatt hour. So for example, right now in Ontario, between 7 p.m. and 7 a.m., so overnight, you're paying the lowest rate. You pay about 8.2 cents per kilowatt hour. During the day, you pay about maybe somewhere in the neighborhood of about 17 cents, maybe, something like that, per kilowatt hour. And yeah, so that's, we pay, and there's a mid-peak rate too. So it's called time of use. So depending on when you use your electricity, you pay a rate accordingly. On the weekend, it's at the lowest rate for the entire weekend, stuff like that. So there is a cost, and I would like you to do a cost comparison. So for example, how much does it cost for a solar panel to produce a kilowatt hour? Now, I don't mean like, okay, so the way you have to think of it is like this. You build a solar panel. Now, over its lifetime, let's say 40 years, it'll produce a certain amount of power, okay? A certain number of kilowatt hours of energy. Now, the only real cost involved in running a solar panel is the cost of manufacturing and installing it. Okay? So solar panels can be expensive, but then they produce power for a really long period of time with basically no additional cost. Whereas anything with moving parts that turn turbines and stuff like that, you'll have regular routine maintenance. Okay, where just like a car, like it has all these moving parts, well, you'll have to replace moving parts and service those moving parts from time to time. Where solar panels have the benefit. They do degrade over time, but it takes a long time for them to degrade. Okay, anyway, I'm going to show you what I expect, okay? Now, I'm not going to lie, this is not my work. It's a former student's work, but I thought it was pretty good, okay? So let me do one for you so you don't have to do it. So I'm going to check off nuclear power. You can just copy this one from me. So nuclear power, what is it? Well, nuclear power is when we use, in the case of a nuclear reactor, we split atoms in the reactor. Okay, so there's two types of nuclear reactions, fusion and fission. Fission is splitting atoms. Fusion is the opposite, it's fusing them together. Both produce tremendous amounts of energy, but fusion is very difficult to do. The sun does it. Okay, fission is relatively easy to do. And when you think of a nuclear bomb actually does both of those things these days, but the original bombs that they created were fission bombs. In other words, they just split atoms, and then they learned later on how to make a fusion bomb, which uses fission to create a tremendous amount of heat, and then that heat in turn creates a fusion reaction. And then you get an extremely powerful weapon. Okay. Now, nuclear reactors typically just use fission. I'm not aware of any reactor that or at least not a practical one that's actually used in general. Maybe there's one that they're working on, but they use fission. So there's several in Canada. Okay, where they use nuclear reactions, splitting atoms to create energy, and it's a controlled reaction. It's not like dropping a bomb where you get all the energy released in one shot. You release it gradually. It produces a tremendous amount of heat. And here's the thing, you're not burning anything. So here's a picture of the nuclear reactor in Pickering. Okay, so that's a nuclear power plant. That is not fossil fuel. You're not burning anything. That is water vapor. It's steam. Okay, so here's the description. The description is, the student put it in her own words, nuclear power plants, okay, you can read it for yourself, but okay, they heat water to produce steam. You don't need to give me, like I said, a graduate level explanation, okay, of how nuclear power works. You can find that online, but I don't want to see that in your own notes in this assignment, because that is beyond the scope of this course. We just want to give just a sort of a cursory description of it, which means just a general description of how it works, basically. Now, I found this, you can find this diagram online. The student found it, okay, but it's easily found. Schematic diagram of a nuclear power plant. Okay, so what happens is very simple. The nuclear, well, not very simple, I shouldn't say that, but the nuclear reaction takes place here in what's called the core. Okay, and in the core, that's where the nuclear, like the uranium or whatever it is they're using as their fission source, the uranium atoms are being split. Okay, it gets really hot in there. You pump this water, okay, through here. So like what's happening is there's very hot liquid goes through this pipe, okay? It sort of comes out here like this. And then that in turn heats this water that's completely separate. Okay, it's completely isolated from each other. Heats this other water into superheated steam. That steam follows this path through this pipe. And then the pressure in the steam can spin this turbine, and spinning the turbine creates electricity, and the electricity goes to your house. Okay, through the transmission lines. That's basically it. Okay. Now there's other things here. There's there's a condenser. This cools the water, and then the process restarts. Okay. And sometimes they off-gas some of the hot water, so the warm condenser water will come out in the form of steam, and that's what you're seeing coming out of these, columns, pillars, or whatever you want to call them. They look like smokestacks, but they're not smoke because you're not really burning anything. It's just water vapor. It's just like if you're boiling water on the stove, you see the steam rising out. Same thing. Okay, so what are the pros of nuclear power? This student felt like the primary pro was that it's reliable. Okay, reliable basically means you can just turn it on anytime you want to produce power anytime you want. And it's not going to, like, you know, be a function of whether it's day or night or how much wind there is. So it's reliable. And that's probably the primary pro. That's a good one. It has low operating costs, believe it or not. Okay. It takes a very small amount of fuel. I'm going to add something to this. Okay. A tiny fuel pellet, probably the size of my thumb, produces a year worth of power for a house. And you get like just a tiny, tiny, tiny fuel pellet for that. Literally the size of a grape. Okay, could power my house for a year. It would take, if I was going to power my house with coal, it would take literally metric tons of coal to power my house for a year. Not so for nuclear power. It's an extremely dense energy source. Okay. Anyway, nuclear power, this is a big one too. Low greenhouse gas emissions. Basically, there are no greenhouse gas emissions, but it does take some greenhouse gas emissions when you're building the plant. Okay. So it has very low greenhouse gases. Okay, and that is key in the 21st century. We want to reduce our carbon emissions because global warming could become a catastrophe for our planet. Okay, so lowering greenhouse gas emissions, those are all good things about nuclear power. Now, what is the cost of running a nuclear power plant? Well, as of May 2016, you could probably find an updated value for this, 6.8 cents per kilowatt hour. Okay, now I know it says that right over here, but yeah, 6.8 cents. So, obviously there's more to it than, okay. So like we pay 8.2 cents at the lowest rates, but there's also costs in transmitting and maintenance and everything else. And that's where the additional costs come from. Hydro is supposed to be not for profit. I'm not sure if these companies really are, so don't quote me on that. But anyway, that's it. 6.8 cents is basically the operating cost of a nuclear power plant per kilowatt hour. That's pretty good. Okay, she added this 2 grams of carbon dioxide per kilowatt hour, 4 grams per kilowatt hour in a 2017 study. So interesting. Okay. Now, what about the cons? So, nuclear power does have some cons, as you can imagine. Okay. For one thing, the waste, you don't get very much waste, and it's all solid. That's actually a good thing. But the waste is extremely toxic. Toxic, and it's toxic for 10,000 years. So what are you going to do with it? Where are you going to put it? Well, what they typically, the strategy now is to bury it. Some people say, well, that's not good. But I mean, look, you got the uranium, which is already radioactive, from the earth. In a way, you're just kind of putting it back. But the difference is you're putting it back all in one place. Not only is that waste extremely toxic, it's also extremely dangerous. That you could use it to make a dirty bomb, it's called. So you cannot allow people to access that. So what they do now is they encase it in concrete, in tons of concrete. So like you've got your spent fuel, you put it in an old mine shaft or whatever deep in the ground, and then you encase it in a thick container of concrete. And this is to prevent people from ever being able to access it again. Now, even though it's encased in concrete, you still can't go near it. It's still like that radiation can penetrate the concrete and make you quite ill. Okay, maybe give you cancer and stuff like that. Okay. Anyway, nuclear power produces radioactive waste, so that's what she wrote as the con here. Okay, and can be dangerous in the wrong hands. So in other words, you cannot allow a rogue operative to get spent nuclear fuel, because that can be used to make an extremely dangerous bomb. Okay, and so that's it. All the other forms of waste that we get from burning fossil fuels and everything, they're basically harmless, right? Except for the environment. Yeah, but nuclear waste is a whole different level of toxicity there. Okay, so even though you don't get very much waste, and it's all solid waste, it's still extremely toxic, and that's a con. There's no two ways about it. Nuclear accidents happen. So Chernobyl, if we were in class, I'd show you pictures of Chernobyl here. Chernobyl is probably the most famous one that happened in 1986, where these guys operating a plant in the Ukraine area, okay, very close to a city of Chernobyl where there's about 50,000 people living there at the time, and this plant exploded basically due to a series of mistakes and some incompetence going on in there. It exploded, okay. And it didn't. Don't picture it like an explosion, like a nuclear bomb going off. It wasn't like that. Basically, the control rods overheated. There was a kind of non-nuclear explosion. I got to emphasize non-nuclear. It was as a result of the tremendous heat coming from the nuclear reactor, but the explosion itself was non-nuclear. What happened was it did kick up, though, into the atmosphere an extremely large amount of radioactive dust. So that spread out into the surrounding area and settled on the ground. Okay, and it's surrounded by farmland and stuff like that. So, yeah, not so good for the farmers. What happened, not for anyone, okay, if you're living in the city of Chernobyl, of course, now you've got radioactive contamination. And it's going to be, that whole area will be radioactive for thousands of years, right? Now, the radiation level has subsided enough that you can make short visits to it, and I would encourage you, if you're curious, to look up what Chernobyl looks like. If a good one to watch is on Netflix, David Attenborough, A Life on This Planet. Just look up A Life on This Planet on Netflix. It starts out with him walking through the ruins of Chernobyl. Now, if you've ever wondered what a city would look like if it was never destroyed by a bomb or a massive or natural catastrophe or anything like that, everyone just left. In other words, like, let's say we're living here in Ottawa. What if we just left? What if we just walked away? We left our houses. We just left everything. We left our classrooms, our schools, everything, and, you might have stuff on the table, like, so they evacuated. Maybe you're sitting down for dinner and you got the call to evacuate. Well, like all those plates and everything's still on the table, and you walk away and you never come back. Well, that's what happened to Chernobyl. And, it's amazing how over time nature has completely, is sort of destroying that city slowly. Okay. And the forest is now growing again in Chernobyl, and there's like all these animals that have not been seen in decades, that were once considered rare, who are making a comeback because everyone left. It's not funny. I'm laughing just because the animals have strangely benefited from, for them the nuclear waste and the radioactive dust is less of a threat than we are, okay, as a species. And so they're back. There's something on YouTube called The Radioactive Wolves of Chernobyl. So if you're curious, look it up. It's kind of interesting. But anyway, nuclear accidents are definitely a risk. The Canadian reactors are considered some of the safest in the world because we have buildings to contain the dust in the event of a meltdown. And we also use heavy water as a moderator, where they used carbon rods, okay, as the moderator. And the rods caught fire in Chernobyl. That's really not possible for the heavy water. So anyway, the feeling here in Canada is that an accident would be extremely unlikely. But, look at the Fukushima plants that were in Japan. They had a tsunami, and that was really bad for the reactor there. But, maybe not such a good idea to build a nuclear reactor along fault lines and where tsunamis might be, in an area might be prone to a tsunami. Not such a good idea. So nuclear reactors have their place. Canada's probably a perfect place, the Canadian Shield. It's stable, geologically stable region. And so an accident would be extremely unlikely here, at least a natural one. So that's it for nuclear power. Okay, so this is what I would like you to do. You don't have to do nuclear power. You can copy this one into your notes. Okay, but please do the other ones like this. So exactly like what you see here. So please, guys, this is your list. Okay, I'm going to circle them one by one. Make sure you do hydro, solar, wind, and then for thermal, make sure you do coal, natural gas, and biomass. Okay, those three things. Also geothermal, which doesn't turn a turbine, but just do it anyway. And then finally tidal. So you have 1, 2, 3, 4, 5, 6, 7 total resources that you were responsible for. They are in the textbook if you're really curious and you just want to read it there. But otherwise, online is quick and easy. So look it up online. But please don't just copy and paste the words. The diagram's fine, not the words though. Okay? The words need to be your words. And you just read about it and then just write a short summary. It's very simple. Okay, so that's the resource assignment. This will be included on a separate quiz. Okay, and I will let you know about that later in the week. Now, in case you're wondering, I watched this documentary, Michael Moore. I feel like not everything that he says in this is correct. Like he talks about electric vehicles, he talks about how you power them and everything else. And, he's kind of down on everything. But you know what? It's a bit controversial, but he does say some important things, some good things in it. In case you're wondering if you want to watch it, like I said, take some of it with a grain of salt. I can tell you he talks about solar panels that only last 10 years. That's just not true. Mine, I've had them on my roof for 10 years, and they're as good today as they were 10 years ago. They're practically like they're brand new, and they're guaranteed for 25 years, and they'll probably last for 40. So that is definitely not the case for solar panels that he talked about. And solar generation it really is the future. It really must be part of our green economy. Okay, so anyway, we'll talk about it later. But if you want sort of a different perspective, you can look at this. It's kind of interesting what he has to say. I really like what he said about biomass. Absolutely 100% worse than burning gasoline, because you're cutting down trees and then burning them. And trees, it's a double whammy on the environment, because trees are a carbon sink, right? They take carbon out of the atmosphere. Now you're cutting that down, so killing the tree and then burning it and putting the carbon into the atmosphere. It makes no sense. But anyway, if you're curious, you can watch that. All right, so that's it, guys. We'll touch base. No class on Wednesday, but Thursday we'll meet again, and we'll have our quiz on heat capacity and efficiency and all that on Friday. Okay. All right. Well, enjoy your day tomorrow. Get caught up on your work. If anyone has any questions or needs help from me tomorrow, I'm around, so don't hesitate to ask. All right. See you later.